Today we're going to go through startup of a Flexion reverse osmosis system. Although this is a Flexion system, this pretty much is the same startup procedure for any RO system. We're going to go through what would be a standard system first. The particular system we have here is what's called a 75% recovery system with a recycle valve. First, we're going to set it up as though it's a standard system for the people who buy standard systems, and then we'll go through the next portion, which would be to set it up for a 75% recovery unit. So the first thing that we're going to do is we need to bleed the air out of the system. Once we've had all the water's been ran to the system, everything's attached accordingly the way it needs to be, then we need to feed the water or the system with water and start to push the air out. To do that, if you look on this incoming solenoid, there's a little plastic handle on the top here, just a little knob that you can turn. If you want to bypass the electronic portion of this solenoid and feed water to the system, then you can turn this to where the system bisects, or the knob bisects the valve. What this is doing is this is letting water go through the system without using the actual electronic solenoid. We're going to do this until we see our pressures pretty much regulate. There'll be a slight difference on a new system. You'll see maybe 3 to 5 pounds difference between these two gauges. But when you look at the flow meters, you'll see a lot of bubbles. This system, you're not seeing it because we've already had this online, but you're going to see a lot of bubbles. And like I said, with the standard system, you're not going to have this particular flow meter. So you'll see bubbles coming through these two right here. What we want to do is we want to run it until we can see the bubbles pretty much decrease and diminish to nothing. Once we've done that, then we're ready to start the system and begin adjustment. So once you've bled your air bubbles out, you're going to flip your switch on, and once the pump starts running, then we can start making our adjustments. Now, when this pump is running, this should always be somewhere above 30 psi. If this particular gauge falls below 30 psi while you're running the system, then you'll keep shutting down the pump to a low pressure fault. So you want to make sure you have adequate pressure here. And you can see right here, we're kind of pushing it to what we need as far as incoming pressure. Now, once we have the system running, we're running now, we're dumping a lot of water to drain because we haven't done any adjustment yet. So what we want to do is we want to start to restrict the flow to the drain, and by default, that'll push more water through the membrane and increase the output. Now, each system has its own standard recovery rate. Some of them are 26%, some of them are 50%, some of them are 60%, some of them are 75% with a recycle. At 50% recovery, what that basically means is you're going to have 1-to-1 on your permeate and concentrate. So if you're at 1 gallon per minute on your permeate, then you're going to be 1 gallon per minute on your concentrate going to the drain. If you're less than 50%, then you're going to have, like, let's say 26%, which would be half of that. What that means is you're going to be putting about 1.5 to drain for every gallon that you make to permeate. If you're 75%, then that changes exactly the other way. You're going to be putting about 0.5 to drain and 1 to permeate. That's about 75% recovery. Okay, we're assuming this is a standard system. Like I said, it doesn't have this, your standard system will only have these two particular flow meters. So what we're going to do on a standard system is we're going to slowly turn in this concentrate valve. And you're going to turn this in until we get whatever your standard recovery rate is. This is a VT2000, so the standard recovery rate is about 63%. So what that means is we're going to make just a little bit more permeate than we are concentrate. So we're going to slowly turn this in until those ratios reflect that recovery rate. Okay, we're about 0.7 on our permeate, and we're about 0.75 on our concentrate, so we need to go a little bit more. Now we're about 0.7 and a 0.65. So that's about 63% recovery rate. Now the thing to remember is this is a ratio. Your system's going to vary. You may not get 0.8. You may get more, you may get less, depending on your TDS level and your water temperature. What we're really looking for is the differential ratio here. So, like I said, we're looking at 63%. Basically, we want just a little bit more permeate than concentrate, which is what we have here. We have a permeate of 7, and our concentrate here is about 0.65, okay? Now, once we've done that, we have a ratio right, then we know we're set up as far as what the system needs to do as far as recovery rate. Now, in certain parts of the country where the water's a lot colder, we're going to need to increase the pressure of the system to get an optimal output. Because as the water gets colder, you need more pressure to push it through the membrane. Now, if you look, our actual pump pressure gauge is at 100 psi, and we're maintaining our ratios. Well, if you figure a 2,000 gallon per day system, you know, you want to get as much output as you can out of it. So what we're going to do is we're going to increase this pressure to 150 psi. So if you come around to this side of the unit, and on bigger units, this instead of being a little adjustment screw, it's going to be an actual adjustment throttle knob, and it depends on which system you have, depends on whether you're going to have a screw or a knob. This particular one's a screw. So what we're going to do is we're going to turn this screw in until we can reach 150 on this pressure gauge out here. So I'm going to slowly turn this in clockwise, watching the gauge, until I get that up to 150 psi. And once I'm at 150 psi, then now we're going to go back and we're going to check our ratios again. Like I said, we should be making just a little bit more permeate than we are concentrate. So we'll readjust until we're right at about 63% recovery. Right here we're at about almost 1.1, and we're at about 0.85 there. So that's somewhere real close to 63% recovery. We're at 150 psi. If you got a standard system, you're done. That's the best that we're going to get out of the system. Now the thing to remember is if you're in a place with cold water during the winter, and the summer when that water temperature increases, then you may want to revisit this because you're going to see your pressure spike. You know, as long as you don't spike above 180, you're okay. But if you do go above 180, then that's when you're going to revisit these settings. Again, making sure this ratio is consistent and our pressure stays somewhere around 150. In the summertime, you may be able to take this all the way down to 100 and not affect your output or your ratio. That's just going to increase the life of your system. That's also going to basically give you the same output without all the, the extra pressure. The startup process for a recycle system is basically the same as a standard system. We're going to get it set up as a standard system first, and then go back and change it to reflect a 75% recycle. So again, we're just walking up to the unit. We bled the air out, we turn the system on. We're going to turn the concentrate all the way out and the recycle valve all the way in, okay? Now we're running just wide open, no adjustments. So the first thing we're going to do is to get it to our standard recycle rate, our recovery rate, which is 63%. So we're going to go to the concentrate valve first, and again we're going to turn this in. We're about 0.7 there, and about 0.7 here on the concentrate. We're going to get that down to about 0.65 and 0.7. So now we're at 63% recovery rate. Okay, we want to recover more than 63%. So basically that means we want to run some of that water back. So your recycle flow rate is going to be the difference between these two numbers, the ratio difference. So we're at 0.7 here, 0.7 there, that's 63%. So if we continue to adjust this until we make this 75%, which would put us about 0.7 and somewhere around in there about 0.35. Now we're recovering 75%, but we need to recycle some of this water so we don't over impact the membranes. So the difference between 0.7 and 0.35 is about 0.35. So our recycle rate, we want that to be at 0.35. So we'll slowly take this valve and turn it out until that reads 0.35. Now when you're reading these flow meters, you're always going to read at the top of the meniscus. That's what this center float is called, is the meniscus. So whenever you're reading this, you want to look at the very top portion of it. That's your actual flow rate. So again, now, like I said, we have 75% recovery. We're returning the difference between these two to the recycle by adjusting the recycle valve. So 0.7, 0.35, and we're at 0.35. So now we're optimally set. But then, again, because of cold water, we have to go back and look at the pressure. So if we go back and look at the pressure, we can see that we're at 100 psi. So this is again where we're going to adjust the pressure up by turning this screw on the side of the pump in clockwise. We're going to slowly turn it in until we get that pressure up to 150 psi. And now we're at 150 psi on the pump pressure. And then we want to go back and revisit our flow meters. Okay, so now that we're recovering 75%, we're at right at 1 gallon per minute that we're making to permeate. And that brings the concentrate to 0.5. So that means we have exactly 0.5 difference here. So our recycle should read right at 0.5, which is exactly where it is. Now what we've done is we've set this up. We're at a perfect 75% recovery rate. We're at an optimal pressure for cold water, so we're getting the maximum amount of output out of this. So basically we're done. Again, you're going to revisit this. You know, as the system breaks in, these can change, so you're going to revisit it at that point, but also as the temperature changes outside, your pressures can change, and you may be able to do some additional adjusting to compensate for that as well. Once everything is set up, you're completely done, everything's running good, then you're going to go back to your solenoid, and now we want to take this off a bypass, so it's totally dependent on this electric solenoid to shut it off and on. If not, if we don't turn that back, then it'll continue to run water to the tank and overflow the tank. So we got to make sure you turn this back when you're done so it's in line, and that lets this electronic solenoid operate the water. Because you can see when the water system shuts off, either with the switch shutting it off or with the tank level input shutting it off, that kills the water pressure there. And as the system bleeds off, you'll see both of your incoming gauges bleed all the way down to zero. That lets you know that the water shut off and you're not going to be pushing water through the tank. But this is it in a nutshell, and I'm sure you're going to have questions because it's easy for me to explain. I've done it 100 times, and maybe I didn't explain it exactly the way that you understand it. But at least you have a baseline now to kind of get an idea of how to start. And, you know, obviously you can always call us 1-800-608-8792 or USWA, and we can walk you through any of this. This is the Flexion unit startup process.